Hi guys, we are going to write a simple PLC logic program that will control electric gate or electric door in such a way that the door can be going forward and backward operation. That is a reversible control system. So we are going to write a little program using PLC logic system. So these are our variables we're going to use. We're going to use input variables 1, 2, 3. These are stop and start push button. And this is our output contactor 1 and contactor 2. Then operation mode will be such a way that is going to be designed such that pressing the start button will put on the motor to run on forward direction. Then pressing a switch 2 will also subject the same motor to run on backward operation. Then shutting down the same motor, we use stop push button. So this is our narrative now. So we are going to go to our PLC environment. This is our interface where we write the program. So we're going to use flip-flop. I'm going to use flip-flop. This is my output device. This is my stop button. Then the second network, we have same we are going to use the same flip-flop. That is my input to energize the backward operation. This is my shutdown device as well. Then this is the gate 2. Then I can use my internal memory bit marker 1.0. Then this one is going to be marker 0.1. All right. So this is my forward operation push button. Going to be start. To start my operation on forward direction, I use this. To shut it down, I'm going to also use this push button. And this is my K1, that is my forward contactor. There's going to be another K2, my backward contactor. And this is my reverse operation push button. And it's also my stop push button. All right, the logic is complete. So we're going to simulate. Take a look at this portion. This is my gadget. This is where I start and stop. The PLC is also embedded right inside here as well. So I will save the logic. It's a very simple program for a beginner in PLC system. If you are aspiring to go into automation, so this is the best place for you to come and learn step by step by using application software as well. So let's see if we can simulate. All right, this is my start push button. This one is my start operation for the forward operation. This one is shutting down that forward operation. This one is to start the backward operation, and this also shutting down backward operation. So let's simulate and put it on and test. All right, this is my simulation logic. This one is true now. By pressing this, I have output here. By pressing this again, the system shut down the forward operation. By pressing this other switch again, I put on this other system. All right, this one is not going. Let's see what is issue here. Okay, this one is on, this one is off. Okay, the issue is our tagging. We have a wrong tagging here. So this one's supposed to be our reverse start, to start reverse. So we're using reverse start here. All right, let's try again. Let's go for forward operation once more. Lamp is on here. I shut it down here. Backward operation is on. This one is also on. Shut it down from here. All right. In a scenario whereby I want to use this logic to control a gate, and the forward operation for the gate to open is initiated, and peradventure I discover that I don't want the gate to open again, I want the gate to close immediately, I can also initiate another command to instruct the gate to close immediately instead of opening. So there is also a logic we can edit this place and add another function that can select the two operations simultaneously. So we can do that by adding a branch here, and put our reverse operation here. The same thing is applicable here. You add the operation by adding this other logic. Okay, and I use forward here. Start forward here. Okay, so with this now, if forward operation is initiated and backward is also needed, once you initiate the backward operation, the command will be reversed immediately. So let's test and confirm. Okay, take a look at the simulation now. This one will be on now. I put on the system, this one is on. If I press this other one, this one will reverse immediately. If I press this one again, this one will reverse immediately. All right, there's one other aspect of this particular design that I want to draw your attention to, and which is interlock system. Interlock system here to interlock this operation. But with the forward and the fast operation, we can override it. Like I said before, if forward operation is on, backward can also be initiated. Because if I open my gate and my gate is opening and I discover that I no longer need the gate to be open, I want it closed, I can't be waiting for the gate to open fully before I initiate the command of closing. So I can override that opening and close it back by adding this particular additional logic. So that whichever direction operation that is initiated, the second operation can override that same function. That is what I have here now. All right, let's test once more. Um, okay, supposing I want the forward operation to come up, I put it on. This is my forward operation. Now I want to shut it down. I shut down by shutting down from here. I want to put on this other backward operation for the door to open or for the door to close. I press here. This one come up. Now, if this one is in operation, I want to initiate this one immediately. I can press this button. It can now override. And this function is only applicable for a smaller induction motors. Take note, for smaller induction motors. If we are writing a program for heavy induction motor, we need to introduce what we call a cool down duration by incorporating a timer to the system. So when you press this direction, before this one will come up, this one has to shut down before you initiate command for this one to come up again. So in that case, we need to incorporate a timer system so that when this one is working,